vector subtraction. The difference A minus B of two vectors A and B is defined as the sum of the vector A and negative of B, that is minus B. Therefore, A minus B is equal to vector A plus minus times B. Therefore, it becomes ordinary addition of two vectors. Now, following laws follow directly from the definitions defined above. First, A plus 0 is equal to a vector, called identity law. Second, A plus negative of A is equal to 0 vector. Third, A plus B is equal to B plus A, called commutative law of addition. Fourth, A plus B plus C is equal to A plus B plus C, called associative law of vectors. Fifth, m into n times vector A is equal to n into m times vector A is equal to mn times vector A. Sixth, m plus n times vector A is equal to m times vector A plus n times vector A. Seventh, m times A plus B vector is equal to m into A vector plus m into B vectors. Fifth, sixth and seventh, they are called distributive laws. And eighth, if A plus B equal to C, then A is equal to C minus B. Next is collinear or parallel vectors. Vectors which are parallel to the same straight line are called collinear or parallel vectors. If two vectors are not parallel, they are non-collinear vectors. Two vectors A and B are collinear if there exists a scalar x belong to R such that A is equal to x times B. Further, if x is greater than 0, then A and B have the same direction and are called like vectors. If x is less than 0, that x is negative, then A and B have opposite direction and are called unlike vectors, coplanar vectors. Three or more vectors are said to be coplanar if they are parallel to the same plane. If they are not parallel to the same plane, they are called non-coplanar vectors. Next, we define linear combination of vectors. A vector R is said to be a linear combination of the vectors A, B, C, dash dash if there exists scalars x, y, z, dash 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 such that R is equal to xa plus yb plus zc plus so on. Linearly independent and dependent set of vectors. First we define linearly dependent vectors. A set of vectors A, B, C, dash dash are said to be linearly dependent or L full stop D if there exist scalars x, y, z, dash dash, not all zeros. I repeat, not all zeros, such that xa plus yb plus zc plus so on is equal to 0 vector. Then we define linearly independent vectors. A set of vectors A, B, C, dash dash are said to be linearly independent if xa plus yb plus zc plus so on equal to 0 implies x equal to 0, y equal to 0, z equal to 0, all scalars are zeros. That means xa plus yb plus zc plus so on is equal to 0 only in first case, only in this case when x and y and z are all scalars are zeros. Note that two vectors A and B are dependent vectors if and only if they are collinear, and if A and B are independent, they are non-collinear. Note 2, three vectors A, B, C are dependent vectors if and only if they are coplanar, and A, B, C are independent, then they are non-coplanar.